Welcome to lesson number 6, where we're going to learn how to add and subtract rational expressions. This is our last lesson in Unit 7, Rational Functions. In this lesson, we will cover the unit check-in, our guiding question, the steps to solve these sorts of questions, try some practice questions, and I'll leave you off for the IXL work to do on your own. So this is the last lesson, lesson 6 in our unit. After this, we're going to have a review and test. Our guiding question. Is the process of adding and subtracting rational expressions, remember with polynomials, the same as with integer fractions? So adding fractions, subtracting fractions, how is that similar to rational expressions? So the answer is yes. Just like we would add or subtract fractions with integers, we will do the same with rational expressions. So here's the steps we're going to solve, and I'm going to first solve a regular fraction equation, and then I'm going to do it with rational expressions. So step 1, turn all expressions into fractions. So the only thing I don't have as a fraction is 2, and of course I can write 2 as 2 over 1. So I have 3 over 2 plus 5 over 6 plus 2 over 1. Okay, step 2, I need to determine the LCM of the denominators, the least common multiple. Well, the least common multiple of 2, 6, and 1 is actually 6. How do I get 2 to 6? I have to multiply it by 3. And then how do I get 1 to 6? I got to multiply it by 6. 6 to 6, I don't have to do anything. Alright, so 5 over 6 is going to stay the same. 3 over 2, I'm going to multiply that by 3 over 3. And 5 over 6 is not going to change. And then 2 over 1, I'm going to multiply that by 6 over 6. Okay, so now I'm going to step 3, multiply each expression by the LCM. I get 9 over 6 plus 5 over 6 plus 12 over 6. Remember, you can't add fractions straight across, so that's why I had to do this. I had to get the same denominator. Now, step 4, I can combine all terms. 9 plus 5 is 14, plus 12 is 26, all over 6. And then simplify any remaining pieces. Both of these numbers are divisible by 2, so I can simplify this to be 13 over 3. And this is my final answer. Now, the same process, we're going to use rational expressions. Alright, let's try this question. So step 1, turn all expressions into fractions. C over 4 is already a fraction. 3c, I'm going to put that over 1. And 6, I'm going to put over 1. Step 2, determine the LCM. My LCM here is going to be 4. So this first fraction I do not need to multiply by anything. The second one, I'm going to multiply the top and the bottom by 4. And same thing for 6 over 1. Let me simplify this. This remains c over 4. This becomes 12c over 4. And this becomes 24 over 4. Add all those together. C plus 12c plus 24 all over 4. And now let's simplify. C plus 12c becomes 13c plus 24 all over 4. It's 24. I can't simplify it any further, so that's my final answer. Alright, let's solve this one. First, I'm going to change everything to a fraction. So I got q over 5q minus 2 plus 3q over 1. Now my least common multiple here is actually going to be 5q minus 2. So this first fraction, I'm not going to do anything to it. The second one, I need to multiply the top and the bottom by 5q minus 2. That's a 1. That's going to give me q over 5q minus 2 plus this bottom will stay as 5q minus 2. The top, I need to distribute this 3q into both terms. It becomes 5q squared, 15q squared minus 3q. And that's all over, not minus 3, minus 6. And that's all over 5q minus 2. Now I can combine these together. I get q plus 15q squared minus 6q all over 5q minus 2. And I can simplify this further. Q minus 6q is going to give me negative 5q plus 15q squared, all that over 5q minus 2. And I can actually simplify this even further by pulling out on the top a negative 5q, and I get 1 minus 3q. and then on the bottom I get the same thing, 5q minus 2. So you got to keep simplifying as long as you can, and if you can cross things out, you need to do that. On this one I can't cross anything out because the 2 and the 1 here don't have the q term, so this is the simplest it gets. Okay, let's solve this one. Let's start by changing everything to a fraction. I get 5q squared minus 26q plus 2, and then 3q is going to be now over 1, and 6 is also going to be over 1. Okay, I try to factor this bottom denominator, and you should always do that. You should always try and factor upon the quadratics if you can. But you won't get a whole number answer, so that actually is going to stay as is in the simplest form. And because these other two terms are both 1, that's going to be our LCM. So our expression is going to become this first term, and then the second one, I'm going to actually multiply the top. Oops, that's not a g, that's a q. I'm going to multiply the top and the bottom by that whole denominator. 5q squared minus 26q plus 2. And then in the denominator, I've got the same thing. And same thing for 6. Plus 2, all that over my expression. Okay, so now we got to simplify this. I'm going to go ahead and just combine all of the tops. And actually before I do that, let's FOIL this out. 3q times 5q squared is going to give me 15q cubed. 3q times negative 26 is going to give me negative 78q squared. And then 3q times 2 is going to be plus 6q. Now let's do this one. 6 times 5q squared is going to give me 30q squared. 6 times negative 26 is going to give me 156 q, and then 6 times 2 is going to give me 12. Okay, so now all of these top numerators are going to add together. So I'll have q plus 15q cubed minus 78q squared plus 6q plus 30q squared minus 156q plus 12, and all that is over 5q squared minus 26q plus 2. Okay, we need to simplify that more. I need to make some room here. I'm going to go ahead and erase all this stuff. And I'm going to simplify that numerator. Alright, gotta get all these lines here. Alright, let's simplify that numerator. How many q terms have I got? I've got a q here, that makes 7q, and then a 56q here. So all in all, that makes negative 149q. And then I've got only one cubed term, 15q cubed, and I've got negative 78q squared and 30. Together that gives me minus 48q squared, and then lastly I've got 12. All this is going to be over 5q squared minus 26q plus 2. Okay, now I just need to ask a question. Can I simplify this any more? Are any of these terms divisible by the same thing? Not all of the first terms, the numerator are divisible by 2, and neither is the bottom. So this is actually going to be my final answer. Alright, last question. I know this video is long because these questions are probably the hardest thing that we've ever done. But let's solve it. So I've got another quadratic here. This one actually you can simplify, so let's do it. First thing before I do anything else, and you'll see why. So negative b would be 13 plus or minus the square root of b squared, 13 squared, minus 4 times a times 6 times c times 7, all that over 2 times 6. Okay, we do this, we simplify. We get x minus 7 over 6 and x minus 1. Now, this is in fraction form, so we need to change it. And we multiply both by 6, so we get 6x minus 7 and then x minus 1. Alright, now you might see why that works, because I have 6s minus 7. Oh, sorry, I put an x, but it's supposed to be an s. So let's rewrite this expression. I've got 8s over 6s minus 7 times s minus 1 minus s over 6s minus 7. Okay, notice that one of the terms over here is there, but not the other one. So my LCM is going to be both of them. So I need to multiply s over 6s minus 7 by s minus 1. The other term I don't have to do anything with. Okay, so then I get 8s, and I'm just going to kind of combine these right away. S times s is s squared, and then s times negative 1 is minus s. So we got s squared minus s. And then all this is subtracted. Okay, and then on the denominator I'll have 6s minus 7 times s minus 1. So let's simplify this. That gives us negative s squared plus 8s plus 1 all over 6s minus 7 s minus 1. Now you need to ask the question, can you do any more simplifying? You could try simplifying this numerator, but I did it and it didn't work. So this must be my final answer. Alright, that's it. Congratulations, you made it to the end of this very long video. Here is the Excel for y'all to work on, Algebra 2 in 6. Please be sure to send me an email or join me during my office hours on Zoom with any questions. Best of luck.